Well, good morning. It's nearly 10 o'clock, so we'll be starting very soon. Welcome back to everybody. Thanks for joining me for another sprinkler talk. I don't know whether you can see me or not. I have told my webcam to be live, but I can't see it on my phone. But never mind. The main thing is the audio, and I'm confident that's working. So yeah, we did 33 episodes of Sprinkler Talk last year in 2020, and now we're starting back up again. So I've definitely got another 10, 11, 12 maybe talks up my sleeve. But yeah, we'll just see how far we go. I was intending to have a little bit more of a break from doing Sprinkler Talk, but because of the new lockdown, it seemed like a sensible time to start it back up again, because I know that a lot of you, like me, are at working from home now, and yeah, it's nice to have something to tune into, something to keep your kind of interest up and extend your knowledge on sprinklers. So yeah, we're going to start this back up again today. So this will be every Thursday, 10 o'clock. If it ain't broke, don't fix it, I guess. So we're going to carry on, same time, same day. And so this is going to be episode number 34 of Sprinkler Talk. And we're looking at void protection and a little bit on alternative ceiling constructions as well, which kind of link together really, the ceilings and the void space. So yeah, thanks again for listening. Thanks for joining in. Remember to spread the word amongst your colleagues. Have a look on LinkedIn. I know we are advertising our Sprinkler Talks on LinkedIn. So if you could like those comments or share those comments, then that will really help to spread the word out there. And remember that all 33 episodes, I believe, are on our YouTube channel. For you to watch back again, or maybe if you're new to Sprinkler Talk, then so there's lots and lots of presentations already on our YouTube page. So just search for Project Fire in YouTube, and I'm sure you'll find them. Project Fire, Sprinkler Talk, those sorts of words into the search, and I'm sure it'll come up for you. Okay, so let's make a start then. So first of all, talking about ceiling voids, and I've got a few questions there which I'm going to go through. So why do we have ceiling voids? Do we need them? Well, no, not really. But it is very convenient to have a ceiling void, depending, I suppose, on the application that we're dealing with, what kind of building we've got. But it's an area which we can hide lots of services, so we can keep them out of sight from the general public, from the people that are kind of using the building day to day. So we can put lots of services in there. What equipment might we find in a ceiling void? So yeah, lighting fixtures. In the room where I am at the moment, it's a false suspended ceiling. So we've got our lighting units as part of that assembly. Obviously, all the wires from the lights are going to go into that ceiling void. We might have air conditioning. We might have heating. Lots of electrics. Ducts, for example, cable trays, all that sort of thing is what you might find in a ceiling void. Dangers for fire. Essentially, like electrical equipment, should not be, electrical equipment that is working well shouldn't cause a spark. But that wherever you find lots of electrics, there is a chance of a spark. There is a chance of a kind of a short fuse or a spark being created, and that is obviously a danger for fire if you've then also got combustible material in your ceiling void. So if you've got, say, a chance of a spark and you've got combustible material within that ceiling void, then obviously there is a danger of a fire catching hold and may spread quite quickly throughout the ceiling voids. So what can be done to protect them? Well, we can have fire detection, of course. So we can have smoke detectors within the sealing void, which obviously give us an early warning of any fire. We can sprinkler protect them, which is what I'm going to talk about today. And then the other thing, as with lots of other applications of sprinklers, sprinklers aren't kind of the only answer. Sprinklers are always used in conjunction with other things, say such as fire detection, but also in terms of compartmentation of sealing voids. So again, we're looking at, if there is a fire, we're going to contain it within a given area. So a lot of industrial buildings, some of the walls, they won't be full height, but some of them will be, and that is to provide compartmentation between different areas of the sealing void, stopping the fire spreading from one area to another. And that's where we have pipes and services kind of penetrating through the compartment on occasion, and obviously that's when this fire stopping comes into place, which I've talked about before, the importance of fire stopping. We don't just want to knock a hole through, stick a pipe through, and then leave a gap, because that's when the fire could spread through one compartment into another, which is obviously what we don't want. So that's a little introduction on sealing voids. You probably knew all of that already, but that's just like an introduction to the topic. But obviously I'm going to be focusing on sprinkler protection. Oh, that's a note there to kind of remind me. So often in where we have sprinklers in sealing voids, we have to deal with a lot of obstructions. So obstructions might come in the form of columns, sort of pillars, supporting pillars. But in the case of sealing voids, it's often ducts. So air conditioning ducts, for example, are a big thing in voids. So we need to place our sprinkler heads sort of around these obstructions and underneath obstructions. And there's lots of rules in the British Standard in terms of explaining how to deal with those obstructions, depending on how big they are and the distance from the ceiling, etc. So this is just a note to you, to say that I'm going to go through obstructions in detail. I'll split that into two sprinkler talks. So that's going to be sprinkler talk 41 and 42. I'm going to talk to you about obstructions, but not today. So protecting voids with sprinklers. So again, I'm taking this from BSEN 12845 or 12845. That is the main standard which we use in the UK for dealing with automatic fire sprinkler protection. And it says here in section 5.4, protection of concealed spaces. So for whatever reason, I guess because concealed spaces are a bit more general, but that's the term that is used rather than voids. They talk about concealed spaces, but basically it adds up to the same thing. So 0.8 meters, that is the magic number, if you like, and I've kind of put that in bold here. So 0.8 meters, 800 millimeters, that is kind of the key number. So it says, if the height of the concealed space at roof and floor exceeds 0.8 meters, these spaces shall be sprinkler protected. So that's a nice, easy, sort of black and white option. If the void is greater than 800 millimeters, then sprinkler protection is required. If the ceiling void is less than 800 meters, then sprinkler protection may be required. So again, it's important just to kind of get that distinction. It's not a case that less than 800 meters you don't have to sprinkler protect, but you may not sprinkler protect depending on a few factors. So we have no combustible materials, and again that's a bit of a grey area. The standard does not tell you exactly what is a combustible material and what isn't, and well, does that count? Or well, I've got a little bit of combustible material here, but most of it's fine. Again, we don't have that kind of detail. So somebody, I guess a fire engineer would be qualified to answer that, but yeah, somebody has got to make a decision as to whether or not there are combustible materials in the void. From a sprinkler contractor's point of view, I guess they would just say, a note on the drawing, I've not put sprinklers into this void because it is 700 millimeters, but this is on the basis that there's no combustible material. So just kind of leave it at a comment like that, I suppose. And obviously they're going to be the voids need to be constructed with non-combustible materials as well. There is a specific notice here about electrical cables. So we are allowed some cables within the void to still kind of not have sprinkler protection required. So less than 250 volts, single phase, maximum 15 cables per tray are allowed. So again, very specific there in terms of the number of cables per cable tray. So, but that's kind of the main takeaway, I suppose, from this presentation is 0.8 meters, 800 millimeters. If the void is up to 800 millimeters, then sprinkler protection may be required. Anything over 800 millimeters, sprinkler protection is required. Bit more information can be found in the technical bulletins. So again, I have explained this before. We have the British Standard, and then we have the technical bulletins, and those two documents sort of added together will make up what is commonly referred to as the LPC rules or the LPCB rules. So technical bulletin 230 or 230, it talks about protection of roof spaces, floors and ceiling voids. So the word voids does crop up here. And it is basically the same rule, so it's still 0.8 meters, but there's a little bit more detail that's been added here. So up to 0.8 meters shall be either sprinkler protected or compartmentalised by vertical cavity barriers, which shall enclose areas no greater than 250 square meters. So compartmentalisation is not actually mentioned in 5.4, although I think that it would be required under other regulations, sort of non-sprinkler regulations in terms of construction. But here it's kind of spelt out in black and white. We need to compartmentalise it. Barriers no greater than 250. What is a cavity barrier? Well, in the actual technical bulletin there is a little definition there. A separating element that resists the passage of flame, heat and fire gases for a period of 30 minutes. And there's a kind of a British Standard, which obviously gives you more information, BS 476-22. But yeah, it's a 30-minute barrier, fire barrier. So that's up to 0.8 meters. Void greater than 0.8 meters shall be sprinkler protected. Again, similar kind of idea. And then where you have voids which, you've got some of it's more than and some of it's less than. Again, there's a note here that deals with that. So either you sprinkler protect throughout, common sense. You can protect the lower the depth and the higher depth all sprinkler protect. Well, that will obviously work. Or you can compartmentalise so that you've got some areas that are then greater and some areas that are less. You don't need to protect the areas that are less, but you do need to protect the areas that are more. So again, that seems common sense to me to kind of deal with that issue where you've got varying void depths. Another bit here, sort of continuing on 5.4. What's the actual sprinkler coverage? So the protection in the concealed space shall be light hazard when the main hazard is light hazard. I.e., if you've got a light hazard building and you have a ceiling void which is sprinkler protected, then the ceiling void protection shall also be light hazard. Light hazard is pretty rare actually these days, so much more likely to have ordinary hazard. So the protection in the concealed space shall be OH1. That should be in all other cases. And just a reminder, i.e. that means we want 5 millimeters per minute of discharge, a 72 square meter area of operation, and design spacing at maximum of 12 square meters. So in terms of how many heads we require, how they're set out, is all OH1. So if our building as a whole, say, might be OH3, then the void protection will be OH1. Okay, so it's a little bit less than what is down underneath the ceiling. A little bit more here in terms of the pipework. So this is 17.3 of 12845, where it says false ceilings above ordinary hazard occupancies. They may be fed from the same range pipe as the sprinklers below the ceiling. Sounds complicated, not really. That's what it looks like. So we're just using the same pipe, and essentially we'll have heads going up to protect the void, and we'll have heads going down that are kind of poking through the ceiling to give us protection below. But that is in ordinary hazard occupancies. In all other cases, and I guess that means high hazard. I doubt that means light hazard, but yeah, it doesn't actually say. It shall be fed from separate range pipes. So again, it just looks a bit like that. We've now got two pipes going through, one exclusively for the void and one exclusively for the ceiling. A few other points. Again, this is a note in the standard talking about no openings between the ceiling and the void. Okay, if the fire is in the room, we want it to stay in the room. If the fire is in the void, we want it to stay in the void. Okay, that's kind of a general principle of kind of fire management. We don't want it to spread from one area to another. So obviously, if we've got openings, then we don't. Openings are kind of bad in terms of letting fire spread one to the other. So if you've got a suspended ceiling, it is important that all of the kind of grid is filled. If you've got various ceiling tiles that are damaged or missing, then they should actually be replaced so that we're kind of separating the room from the void. Vertical shafts and chutes with combustible materials to be sprinkler protected on alternate floors. So generally speaking, vertical shafts and chutes, they are a what's called a permitted exception. So generally speaking, they are not sprinkler protected, but if they contain combustible material, then they should be sprinkler protected, and that is done, say, with a sprinkler head on alternate floors. So you kind of you sprinkler protect, then you miss a floor, and then you sprinkler protect. There are special rules for ceiling air conditioning plenums. I think that's how you say it, plenums. And there's a bit of information there in Technical Bulletin 230.4.2. What's a plenum? So a plenum is where you're using the void as your heat or air conditioning. So normally with heating and air conditioning, you have a duct that's running through the void, and that is actually at high pressure or low pressure to kind of pull the air through and kind of mix the air through the room. But a plenum means that you're actually using the whole of the void. So it's like the whole of the void is acting like a giant duct to move air through. There's a diagram down here which is showing you, and I've been in a building which has got one of these that's got kind of vents in the floor. It's like a kind of exhibition space I was in, like a stage, and the air is going to go sort of underneath the floor, like a giant plenum underneath the floor, come up through there, and then get sucked out of the top to create this kind of moving pattern of air. So, like I say, there are special rules for plenums, which I won't go into today. I don't think I'll bother covering that on a sprinkler talk. But say if you do come across a plenum, then sprinkler protection, say, has got some special rules there. Sprinkler protection is not required in ceiling voids. Oh yeah, sorry, yeah, I've got ahead of myself there. So now I'm talking about residential buildings under 16925 and 9251. So sprinkler protection is not required in ceiling voids under residential and domestic buildings. Loft voids are included in this as long as they are uninhabited and suitably compartmentalised. So yeah, we don't do void protection under residential and domestic rules, and that includes the new 9251, which I believe is due out this year, had a look at the draft document, and again, that doesn't mention it either. Right, a little bit now about alternative ceilings, just in the last few minutes. So there's a special note about skylights. Again, I'm not going to go into lots of detail. Skylights, generally speaking, won't be sprinkler protected, but large or unusual skylights may require it. I kind of had a look at the rules, and I don't know much about skylights, but I decided from reading the description that the majority of skylights wouldn't sort of trigger this additional rule. Canopies. So canopies would be sprinkler protected, often with a tail end dry system, because obviously they're going to be exposed to the low temperatures. So there's rules for that. In the technical bulletin 221, which is all about schools, there are quite some more detailed rules on canopies, because I think schools tend to go for canopies in a big way. Kind of lunchtime, break time. They want to get the kids out of the building, but they need somewhere to stand and play when it's dry. So they kind of like canopies at school. So there's a bit more detail in there if you're interested in that. And also TB 206.4.3 will also tell you more about canopies. Suspended ceilings. I kind of read this and thought, well, yeah, that's pretty obvious. Use of a suspended ceiling below the sprinklers is not allowed unless the material has been shown not to impair sprinkler protection. So it seemed pretty obvious to me. You can't have sprinklers installed in the ceiling and then put a suspended ceiling below and expect the sprinklers to protect the room because there's a whopping great obstruction in the way now. Where sprinklers are installed below a suspended ceiling, the construction must be suitable to capture the heat. So again, with the suspended ceiling it kind of has to do one thing or the other. It either needs to completely get out of the way and allow the sprinklers above to do their job, or it's got to sort of trap the heat so that the sprinklers will come up to temperature and operate. Finally, I think, if I remember rightly, talking about suspended open cell ceilings. IKEA seems to be a big fan of these. Whenever I'm wandering around in IKEA, they have these suspended open cell ceilings, which means that generally at eye level, you just see a ceiling. You don't sort of notice what's above, but obviously if you stop and look up, as people like me will do, you can see all of their sprinkler protection and all of the services that are connected in the void space above. So a suspended open cell ceiling does not require sprinkler protection below as long as these conditions are met. So it's only for light hazard and ordinary hazard. The open area must be at least 70%. Again, makes sense. So the suspended open cell ceiling must be 70% nothing, if you know what I mean. The openings must be a certain size. There was a comment here that the operation of the sprinkler system must not affect structural integrity of the ceiling or the surfaces, which again is a bit of a obvious thing to say, but yeah, when the sprinklers operate, we don't want the ceiling to fall down or other surfaces to kind of fall off. That's going to injure people down below. So again, that seemed a pretty obvious thing to say. No storage below is allowed, and then the spacing above is not to exceed 3 meters in any direction, i.e. 9 square meters is maximum. Sprinkler heads placed away from the top of the suspended cell ceiling. So again, we don't want to get too close to it. We need a little bit of distance in order for the water to be discharged correctly. And sprinklers placed at overcome obstructions. Yeah, again, any kind of ducts, etc., would need to be protected properly. And again, I'm going to cover those in a later sprinkler talk. All right, and that's it for today. So next week I'm going to be talking about pressure check. So pressure check is a product that we sell, Project Fire sell. and it's all to do with towns' main fed sprinkler systems and the issues of low water pressure. So yes, I'm going to be talking about pressure check, but also I'll be talking about, say, town main fed systems and the kind of the problems of having low water pressure for that. So as per usual, I will hang around for a few minutes and see if there's any questions in the chat. So if you're new to Sprinkler Talk and new to kind of our Blue Jeans system, you should find on your screen somewhere a little option for the chat function. It looks like a little speech bubble on my phone at least. So if you've got a question about today's presentation, about protection of ceiling voids, etc., then you can pop that in the chat, and I'll see if I can answer that for you, or I might get back to you next week, or send you an email, etc. Just a reminder, the email address to send any kind of questions or comments is on the screen there, sprinklertalk@projectfire.co.uk. In February, we have a question and answer session. So again, I'm relying on people sending me questions. If I don't get any questions in, I've got nothing to talk about. So do send me your questions in at sprinklertalk@projectfire.co.uk, and that I will answer them during that session. The technical bulletins, are they available? I mean, yes, they are. I'm a bit nervous about sort of sending you all of them because they are kind of a copyrighted document, so you should all be kind of buying them rather than me sending them. But if there's something in particular that you want to know, then send me an email, and I can sort of photocopy the section that kind of answers that question. But yes, I mean the technical bulletins are published by the fire. But if you look at Risk Authority, RISC, Risk Authority, I imagine you can buy them from them or download them from them. But yeah, I got them as part of the LPCB sprinkler rules, which again are available to buy. I could talk about that another session. But yeah, thanks for that question. All right, I think I'll sign off at that point. So yeah, hope you have a good rest of the day, and I'll see you next week. All right, bye-bye.